So you figured out how to do the product rule, and then you figured out how to do the chain rule to find the derivative of a function. But now you get a curveball, and you have a problem where you have to use the chain rule and the product rule in one problem in order to find the derivative of a function. How the heck do you deal with both of those at the same time? Well, that's what I'm going to show you in this video. In one of my recent weekly live streams, I went over a few problems that involved using the product rule and the chain rule in the same problem. And I think that you might find a section of that live stream very helpful. So I wanted to go back and show you that problem. We're going to be looking at an example of how you can apply both of these methods to find the derivative of one single, fairly complex function. And you may definitely have to be familiar with how to apply multiple of these different derivative tricks in one single problem. So be sure to stick around to the end of the video, and if you do find it helpful along the way, it would be very helpful if you would hit that like button for me. But anyway, let's go ahead and jump into the problem and I'll show you what I'm talking about.
We're going to use product rule and chain rule in order to find the derivative of this function, y equals x squared minus 6, all in parentheses, cubed, and then times 2x to the fourth plus 7x squared, all in parentheses, and then all that raised up to the fourth power. So you can see just by looking at this, first of all, I want to just kind of talk about how you know that you have to use both product rule and chain rule. So I kind of talked about this in my live stream last week, and basically the idea when it comes to chain rule, and you can kind of apply this same thinking to product rule, quotient rule, and chain rule, it kind of works for all of them, is think about what would happen if you actually plugged in some x value into this function. So if we actually took some x and plugged it in right there, and right there. If we were to actually do that, think about what steps you would have to go through to actually find the value that this function would output for that given x value. Basically, what I'm getting at is think about what the order of operations would be that we would have to go through. So first of all, we would have to deal with everything within these parentheses here. Okay. Similarly, we would have to deal with everything within the parentheses here. That would be kind of your first step. Then after that, we would need to deal with each of these exponents. And then finally, the last thing we'd have to worry about is the actual product of these two things. So we would basically figure out inside the parentheses, raise it to a power, and then times it by, what we get for this whole part over here as well. Based on that order of operations, the order that you would kind of go through everything, and I've kind of color coordinated it here. Basically, we would do the green thing first, the orange thing second, and then the red thing third. Those would be kind of the steps you would go through. What that kind of tells you is what order we're going to have to apply chain rule versus product rule, or whatever other methods of taking the derivative we would want to apply or have to apply. So in this case, basically, based on the fact that the final step we deal with, the number 3 step here, is this product, the product rule is going to be actually the first thing we want to think about applying. So we're going to go in reverse order, basically. Since the product of this thing and this thing, the whole parenthesis and the power all kind of in one, the product of those two pieces is the final thing we would deal with based on order of operations. That has to be the first thing that we deal with when we're taking the derivative. So basically, as we're applying product, chain rule, quotient rule, we kind of want to start from the outside and work our way in. Start from the end of the order of operations and work our way back to the beginning. So let's talk about what that looks like, or what that ends up doing. Like I just said, we're going to want to do product rule first. So we want to basically think of the outermost pieces first. So basically, all of that, this x squared minus 6 all cubed, is one thing that's being multiplied, and then the other thing that's being multiplied is all of this. So basically the 2x to the fourth plus 7x squared all to the fourth. So basically the final step, based on order of operations, PEMDAS, the final step would be this product. So first we want to apply product rule. Product rule says that basically we just need to decide which of the two pieces of the product. So since these are the two things that we have to multiply, this whole thing here, and then this whole thing here, those are going to be the two kind of smaller portions of our function that we want to use as our chunks for the product rule formula. So basically what that means is if we just call one of these f and one of these g, we can apply the product rule with this being f and this being g. We could definitely switch those two. It's not really going to make a difference. The equation is going to end up working out exactly the same. But then we can go ahead and go through the product rule that way. So let me just go ahead and erase a little bit of this here, just to kind of clean things up here. I kind of made a little bit of a mess. Based on the product rule formula or the product rule process, what we need to do, now that we've decided which function is our f and which is our g, we then need to find the derivative of each of these things. So the derivative of this and the derivative of this. Now this is where the chain rule is going to come into play, because let's think about how would you find the derivative of this thing here, x squared minus 6 all cubed. You would have to apply the chain rule, because chain rule is going to be applied wherever you have basically an inner function and an outer function. So for example, if we look at what's inside the parentheses here and think of that as our inner function and then this cubed piece as our outer function, we can apply the chain rule to find the derivative of just this f function here. So let's go ahead and kind of make a separate problem out of that. So to find, just kind of taking that separately down here, if we want to find the derivative of this, x squared minus 6 all cubed, we want to find y prime, right? Like I just said, and I went over this in a lot more detail in my chain rule videos that I came out with recently, the live stream that I did last week. I went into a lot more detail about chain rule. Basically, the idea is you're just going to take the derivative of the outside, leave the inside alone. So like I said, we're going to treat this x squared minus 6, what's inside the parentheses here, as the inside function. The cubed piece, basically x cubed, is going to be our outside function. So we would take the derivative of the outside function, the derivative of your variable raised up to the third power, we could do just using the power rule. So we would bring our 3 down in front, lower the power by 1, right? 3 minus 1 is 2. Well, chain rule specifically says we're going to take the derivative of the outside piece, which would give us bring the 3 down in front and lower the power by 1. We're going to leave our inside function the same, so we're not going to change that. And then we're going to multiply this by the derivative of the inside function. Well, the derivative of x squared minus 6 is just going to be 2x, and that would just be by the power rule as well. So this is going to be the derivative of this, so we can go ahead and put this whole thing here, right up here, for f prime. 3 times x squared minus 6 all squared times 2x. Okay, so now that's going to be our f prime. So then same idea here for finding g prime. We want to, let's say we now want to take the derivative of this function here. We're going to say y equals 2x to the 4th plus 7x squared raised up to the 4th. So again, if we're going to take y prime, we want to first think about what is our inside function. So our inside function is just going to be what's inside the parentheses here. So that means our outside function is going to be whatever we get from replacing this whole inside function with x. So that would just give us x to the 4th in this case. So then chain rule would say that we would do the derivative of the outside function, which is x to the 4th. So bring the 4 down in front, leave the base, leave the power, or leave the inside function, what's all in purple here, leave it as it is. So 2x to the 4th plus 7x squared. And then lower our power by 1, subtract 1 from our power, and then multiply this by the derivative of the inside function, so the derivative of what's circled here in purple. The derivative of this can be found just using the power rule by bringing the 4 down in front, multiplying by 2, so that gives us 8x to the 3rd, because we lower our power by 1, plus bring the 2 down in front, 7 times 2 is 14, times x, lower the power by 1, which just makes it a 1, which is just x. So now this is the derivative of this function here. So that is going to be what we call our g prime up here in the product rule formula. So we're just going to go ahead and put this up here. Okay, cool. So we basically had to kind of start with the product rule, break down the product rule formula, which is finding our f, g, f prime, g prime. And then in order to find the f prime and g prime, we had to use the chain rule to do that right here. So now let's kind of go back up to the product rule formula, or the product rule process, which basically just says, once you have found your f, g, f prime, g prime, you just multiply them across. So multiply f times g prime, multiply f prime times g, and then add those things up together. So basically, doing that is just going to give us f times g. So y prime is just going to be this piece here times this whole piece here. So I'll go ahead and put this 4 coefficient out in front. So 4 times x squared minus 6 cubed times 2x to the 4th plus 7x squared cubed times 8x cubed plus 14x. And then we add what we get from multiplying f prime times g. So this whole thing times this whole thing. So in this case, that's a pretty long, drawn out thing here. But this would be the result of that product rule, and we had to use the chain rule to find the derivatives of the individual components of the product rule formula. So in this case, we have now officially applied both the product rule and the chain rule. And maybe this is a little confusing having used y prime so many times, but this is actually the derivative of the original function that we started with. So this is going to be our final answer in this case.
Well, I hope you found that video helpful. If you did, do me a favor, hit that like button down below. It's a huge help to my channel so I can keep making more videos like this. And if you want to keep learning about other methods of derivatives, just go ahead and click on one of those videos over there and keep on learning. Thanks, and see you next time.